Okay, so if we wanted to take something like 8 to the 1/3, we know that we want the cube root of 8. 8 being 2 cubed, this is just 2. And if we wanted something like negative 8 to the 1/3, this would be the cube root of negative 8, which we could write as negative 2 cubed and just get negative 2. However, what if we wanted something like 8 to the 2/3? What should we define 8 to the 2/3 to be? Well, let's think about that for a second. If our rules for exponents are going to hold, this needs to be 8 to the 1/3 times 2, which would be 8 to the 1/3 squared. So if our rules are going to hold, there really is only one way to do this. This needs to be 8 to the 1/3 squared, or the cube root of 8 squared. In which case, for this example, I'm going to get 2 squared, or 4. So we want to do this in general, not just for this one single example. So how are we going to define this? Well, we'll just say a to the m divided by n is going to be the nth root of a to the mth power. So this is the exact thing we did here. Whatever number we have in the numerator here, we could always write it as multiplication and pull it out using our rules for exponents, and then we get the following. Of course, we're still insisting that m and n are whole numbers. We're not allowing anything like pi, and we're not even necessarily dealing with the negatives yet, though we're not going to have to be too careful about certain examples with negatives. Okay, so let's look at some more examples moving forward in the next video.